Hello everyone, we are the senior project team with Woodward. Our project is a laser weld cell. So Woodward is an aerospace company, and right now they use EV welding for a lot of their welding operations. But one of the issues that they're having is they're having a difficult time getting like a high first pass yield because of the weld quality. So one thing that Woodward wanted our senior project team to do was design a laser weld cell that could do the same welding operation, but to see if laser welding would give a better result compared to EV welding. So some of the major specifications for this project all involve pretty much like the vacuum chamber. So one was that the vacuum chamber had to be able to be pumped down to 10 to the negative 2 torr. Another one involved the rotary. We had to select a rotary that could vary between 0 and 100 RPMs with a tolerance of 0.1 RPMs. We also needed to be able to move the wobble head plus or minus 1.5 inches based on the center in the X direction and 4 inches in the Z direction. So this is the design that we came up with. This uses an IPG photonics laser wobble head, and then the laser generators in the back there. And then this whole system is used to move the laser head to align it with the part. And this is the vacuum chamber, and currently in the aerospace industry, they're required to weld all their parts in vacuum pressure. So this is how the operator would use our laser weld cell. If they have a part that they want to weld, they would open the vacuum chamber, insert the part into the 3-jaw chuck, close the vacuum chamber, and then they would use the camera that's mounted on the wobble head to align the wobble head with the weld seam of the part. And that can be adjusted with this turn screw and this turn screw. So this one moves the wobble head in the Z direction, and this one moves it in the X direction. But so once that's aligned, then you would select your program on the HMI, and that would turn on the vacuum pump. It would pump down the vacuum chamber. It would turn on the rotary, which would spin the part, and then it would energize the wobble head. And then once everything's up and running, the laser beam is going to actually weld the seam of the part. Once that's completed, the program will tell the rotary to stop spinning. It will de-energize the wobble head, and the vacuum pump will stop operating. At that time, you can close the shutoff valve and then open the vent valve on the side of the vacuum chamber, and then take your part out and it should be all welded. So due to COVID, we've definitely ran into some issues. Almost all of the components have been delayed in some way, between not having enough time for machining in the machine shop or delays with several components from different suppliers. But all in all, I feel like our team has still been able to complete this project to a good endpoint, and we've been talking with Woodward, and they seem to be also happy with the progress that we've been making.